everyone, and welcome to the deep dive. Today we're going deep into the quantum realm
Yeah.
with this new AWS Ocelot chip.
Yeah.
Really amazing stuff. It has the potential to completely redefine what is possible with computing.
It really does.
And trust me, this is something you'll want to hear about.
Absolutely.
So we're going to be talking about things like drug discovery happening in a fraction of the time.
Right.
New materials
Yeah.
with unheard of properties becoming commonplace, and financial models being able to predict the market with, well, maybe not perfect accuracy, but something way closer than we have right now.
Yeah. It's truly fascinating stuff.
It is.
We're talking about harnessing the power of quantum mechanics to really tackle some of humanity's biggest challenges.
Exactly. But before we get too far ahead of ourselves, let's back up a little bit.
Okay.
What is quantum computing, and why should you even care?
So let's start with the computers we use every day, your laptops and smartphones. Those use bits, right?
Yeah.
A bit can be either a 1 or a 0.
Right.
And that is the foundation of all the calculations and operations that those devices can perform.
Okay, ones and zeros, got it.
Yeah.
But quantum computers, they're not playing by the same rules, are they?
Not exactly.
Okay.
So instead of bits, quantum computers use qubits.
Okay.
Now here's where it gets wild.
Okay.
A qubit can be both 180 at the same time.
Whoa.
Yeah, it's like it's in this fuzzy in-between state.
Okay, that's where my brain starts to hurt a little.
Yeah.
So how does that translate into more power?
Okay, think of it this way.
Okay.
Imagine you're trying to find a specific grain of sand on a beach.
Okay.
A classical computer with its bits would have to check each grain one by one.
Right.
But a quantum computer, using the weirdness of qubits, could essentially check all the grains simultaneously.
So it's like it has a superpower that lets it explore tons of possibilities at once. That's what makes quantum computers so much faster, right? They can just crunch through these problems in a fraction of the time that it would take a classical computer.
Right, and that opens up a whole new world of possibilities, especially for those really complex problems that are impossible for even the most powerful supercomputers to solve.
We're talking problems like simulating complex molecules to design new drugs, optimizing logistics on a global scale, even cracking the codes that protect our online data.
Right.
So it's pretty clear this tech has game-changing potential.
Huge potential.
But there's a catch, isn't there?
There is a big one.
Okay.
And it all comes down to the delicate nature of these quantum systems.
Okay.
They're incredibly sensitive to any kind of disturbance, even the slightest vibrations, temperature changes, stray electromagnetic fields.
Are you telling me that something like a rogue cosmic ray could mess up a quantum calculation?
It sounds crazy,
but
it's true. All of this noise, as it's called, introduces errors into the system. And that's a major roadblock to building reliable quantum computers that can live up to their potential.
Okay, so now we're at the heart of the problem. These errors.
Right.
How do we even begin to tackle that kind of sensitivity?
That's where the concept of quantum error correction comes in.
Okay.
And it's one of the biggest challenges facing researchers in the field.
Really?
Oh, yeah.
Wow.
It's a big one.
Okay, so we'll have to dig into that more after the break. Quantum error correction sounds intense.
It is.
Can you break that down for us?
Well, it's a bit like trying to send a message through a noisy channel. You need a way to protect that information from getting garbled along the way.
Yeah.
In quantum computing.
Oh, okay.
We do this by spreading the quantum information across multiple qubits.
So it's like having a backup system.
Exactly.
Okay.
If one qubit gets hit with noise, the others can help to compensate.
So it's like having multiple copies of the data so that even if one is corrupted, you can still recover the original information.
Exactly.
Cool.
And quantum error correction also involves some pretty clever techniques for detecting and correcting those errors as they pop up.
Okay.
But here's the rub.
Okay.
Traditional methods of error correction are incredibly resource intensive.
Okay.
They require a lot of extra qubits and complex operations, which makes things very expensive and complicated.
I see the problem.
Yeah.
So we need error correction to make quantum computers reliable.
Right.
But the existing methods are just too costly and complex to be practical on a large scale.
Exactly.
So how do we bridge that gap?
Right.
That's where this Ocelot chip comes in, right?
You got it.
Okay.
AWS has designed Ocelot with error correction baked into its very core.
Interesting.
And they're doing it in a way that's both ingenious and dare I say, a bit mind-bending.
Oh,
They're using something called cat Qubits.
Cat Qubits. Okay, now you got my attention.
All right.
This is where Schrodinger's cat comes into play, right?
Absolutely.
I remember learning about it in school.
Yeah.
But a little refresher wouldn't hurt.
Okay, so imagine a cat sealed inside a box, along with a device that has a 50-50 chance of releasing a deadly poison.
Okay, I'm with you.
Now, according to quantum mechanics, until we open that box and observe what's inside, the cat exists in a state of superposition.
Okay.
It's both alive and dead at the same time.
Yeah, that always messes with my head a little.
Yeah, that's a tough one.
But how does this relate to quantum computing and these cat Qubits?
Well, just like Schrodinger's cat, cat Qubits can exist in these superpositions, occupying multiple states simultaneously.
Right.
And this unique characteristic gives them a natural resilience to certain types of errors.
So they have like a built-in shield against the noise that plagues other types of Qubits.
Yeah, it's as if they have this built-in shield.
So it's like these cat Qubits are inherently more stable, less prone to those tiny disturbances that throw everything off.
Exactly.
That sounds like a huge advantage.
It is.
Okay.
And because of this built-in resilience, AWS estimates that Ocelot could achieve fault-tolerant quantum computing with significantly fewer resources than other approaches.
So how many fewer are we talking?
They're talking about potentially reducing the number of qubits needed by a factor of 10.
Wow, a 10-fold reduction? That's incredible.
Yeah, it's pretty impressive.
But it's not just about the cat Qubits themselves, right? It's how Ocelot is architected from the ground up.
Exactly.
Okay.
Ocelot isn't just about fancy qubits. It's a completely new way of designing and building quantum computers.
Interesting. So how are they doing that?
Well, they've integrated quantum components onto a stack of silicon chips. Using fabrication techniques that are very similar to those used in the semiconductor industry.
So they're leveraging existing technology to make quantum computing more practical and accessible.
Precisely.
That's smart.
And because of this approach, they're estimating that chips based on the Ocelot architecture could be up to 5 times cheaper to produce than existing solutions.
Wow, 5 times cheaper.
Yeah, it's a game changer in terms of scalability and cost effectiveness.
Okay, so let me get this straight. Ocelot uses cat Qubits that are inherently more resistant to errors.
Right.
And they've built the entire chip with error correction as a top priority. Plus, they're using existing manufacturing techniques to make it more affordable to produce.
Exactly.
It sounds like they're really hitting all the right notes here.
They are.
Now, it's important to remember that Ocelot is still a prototype.
Right, it is still early days.
But AWS is very optimistic about its potential.
Oh, yeah, they are.
They believe it could accelerate the development of practical quantum computers by as much as 5 years.
At least 5 years.
5 years. That's not that far off at all.
No, it's not.
So what does this actually mean for the average person?
Well,
when can I expect to have a quantum computer sitting on my desk?
Well, we're not quite at the point of having personal quantum computers just yet.
Okay.
But what's really exciting is that the advancements being made with chips like Ocelot could bring practical applications of quantum computing much closer to reality.
So we're talking about things like personalized medicine based on your unique genetic makeup.
Exactly.
Materials that are lighter and stronger than anything we've ever seen before.
Right.
Financial models that can predict the market with incredible accuracy.
All of that and more.
It's hard to even grasp the full impact this could have on our lives.
It really is.
So where do we go from here?
Right.
What's the next step in this quantum revolution? So we've got all this incredible potential on the horizon.
Yeah.
But it still feels a bit like science fiction.
Right.
What can our listeners do right now to prepare for this quantum future?
Yeah.
Should we all be brushing up on our linear algebra?
Well, a solid understanding of linear algebra wouldn't hurt.
Okay.
But it's not a prerequisite for appreciating the impact of this technology.
Right.
I think the most important thing right now is to just stay curious.
Okay.
Keep learning.
Yeah.
Keep asking questions.
Okay.
You know, the field of quantum computing is evolving at an incredible pace.
Right.
So even just keeping up with the major developments can be a challenge.
So where should people go to learn more?
Yeah.
Are we talking about dusty textbooks and obscure scientific journals?
No, not at all.
Okay.
There are actually a lot of great resources available online.
Okay.
For anyone who wants to delve deeper.
Like what?
You've got online courses, blog posts, even videos that break down complex concepts into bite-sized pieces.
Yeah.
And for those who want to get some hands-on experience, there are even platforms like Amazon Bracket.
Oh, yeah.
That give you access to real quantum computers.
Wait, so anyone can just log in?
Yeah.
And start experimenting with quantum computing?
Pretty much.
That's amazing. I might have to give that a try myself.
I highly recommend it.
Okay.
It's a great way to demystify the technology and get a feel for how these systems actually work.
Okay.
Plus, it's just plain fun.
Yeah.
To play around with the cutting edge of computing.
It's like a playground for the future.
It really is.
Okay. As we wrap up this deep dive into the world of Ocelot and quantum computing, what's the one key takeaway you want to leave our listeners with?
I want them to understand that while we've made incredible progress, the quantum revolution is still in its early stages.
Okay.
There's so much more to discover.
Yeah.
So many unanswered questions.
Absolutely.
And that's what makes it so exciting.
Yeah.
You know, we're on the cusp of something truly transformative, and the possibilities are practically limitless.
It's inspiring to think about what the future holds.
It is.
Who knows? Maybe one of our listeners will be the one to make the next breakthrough discovery. That's why it's so important to keep exploring.
Yeah.
Keep pushing the boundaries of what's possible.
Right.
We've only just begun to scratch the surface of what quantum computing can do. So if you're listening and you're feeling that spark of curiosity, don't let it fade.
No.
Dive deeper, explore those resources. And who knows, you might just be the one to unlock the next chapter in this quantum adventure. That's it for today's deep dive.
Well said.
Thanks for joining us.